Is there life in space? It strikes me as the biggest question there is, and it's certainly the question that more people ask me when I wander around the world than any other question. So, Paul, is there life in space?
How would I know? This is really big uncertainty here, because when you go out on a beautiful starry night at the Siding Spring Observatory, you see maybe a few thousand stars. Most of those stars probably have planets, and it could be that a good fraction of those planets have life forms on them. So when you look out at the night sky, on almost all of these dots there's a planet orbiting with something looking back at you, some sort of strange tentacled monstrosity or alien creature. So it could be the universe is teeming with life, and everywhere we see, that star, this star, that star, they've all got highly intelligent civilizations orbiting around them. Or we could be alone in the universe. They could be just dead. That's a pretty big uncertainty.
All right, well, we're physicists, so it strikes me that maybe we need to bring a little bit of form to this question. We use equations, so maybe we can try to capture what's going on in an equation with some uncertainties.
So the normal way this is done is what's called the Drake equation, which is an attempt to not answer the question, is there life in space, but at least break down all the different uncertainties and stack them out so we can see them. I should make it clear that this is a very speculative part of the course. We really don't know most of these things. It's far more, there's lots we don't know about in other parts of this course, but this is at the epicenter of astronomical ignorance, if you like. We really don't know what's going on here. So this is where we get to the wild speculation, we let our hair down, we throw out crazy ideas. So everything we say in this video lesson should be taken with a large pinch of salt.
So we're going to try to figure out how many intelligent alien species are out there.
Okay, so we're going to have an equation with the number of intelligent life forms that's going to be a whole bunch of different things multiplied together. So we'll start off with the number of stars. Clearly, if there are more stars, there's going to be more life forms out there.
And boy, there's a lot of stars out there. So there's 10 to the 11 stars in our own Milky Way. And our Milky Way is only one of a tremendous number of galaxies. I mean, there are hundreds of billions of galaxies out beyond the Milky Way that we can see with telescopes here on Earth.
If you just take the number of galaxies within range of our telescopes, out to maybe 10 billion light years or so, and we multiply by the typical number of stars in a galaxy, you can work out the number of stars within the observable universe, and it comes out as about 10 to the power 23, which is an incomprehensibly vast number, but to put it in perspective, that's about the same as the number of grains of sand in all the beaches and all the deserts of Earth. And that's just within range of our telescopes, whereas presumably it keeps on going much further, possibly infinitely further beyond that.
All right, so 10 to the 23 stars. With that many possibilities for there to be Earths, there must almost be something that looks just like Earth. How could we possibly think that we are it, given that many chances?
So this, if you like, is the space is really, really big argument. Even the universe is absolutely enormous, so huge, so big. How can we be so arrogant as to think we are the only life forms? And some people find that argument pretty compelling. But let's keep on with our terminology. So we now get to the next term. Stars are all very good, but a star that doesn't have planets, you're not going to get life there, unless you get some sort of strange plasma being that lives in the surface of a star. But life as we know it is going to require planets.
So this is not 9, well, it's actually 8 now. We've demoted Pluto since my childhood. So that number is 8 for our own solar system. And we know that from recent surveys of nearby stars with, for example, the Kepler mission, which is a NASA satellite that goes out and looks for planets, that the average star has a planet around it. And that's something that we didn't know 10 years ago.
In fact, probably several planets around it. So we know this number is at least a half and probably 1, 2, 5, 10, something like that.
But to a factor of 10, we know the number, which doesn't sound great, but since we didn't know what it all was at all 10 years ago, that's a big improvement.
So there are going to be lots of planets out there. But of course, most planets in our own solar system are not very nice places for life. Look at the moon, for example. I don't think I want to live there. Your hard radiation, baking heat and freezing cold, no atmosphere, no water. It's hard to imagine life going on the moon or Mercury or Pluto or most of the planets, really.
So we really need to have a habitable planet for there to be alien life. And so clearly the moon, well, it's not really a planet, but it counts. The Earth's habitable. Not really clear anything else in the solar system is habitable. Maybe Mars. So maybe we need to have a look at what is going to be a habitable planet.